Hi friends, Miss Hedequist here. This is the last page of notes for topic 2. This page of notes is going to go on page 16 of your notebook, and we are going to write equations of parallel and perpendicular lines today. Our language acquisition objective is to explain the difference between parallel and perpendicular lines using academic vocabulary. And our essential question, how can equations of lines help you identify whether lines are parallel or perpendicular or neither? So parallel lines, they never, ever, ever intersect. They will never cross, ever, okay? They always, like these red lines, they will never, ever cross. Perpendicular lines, they intersect at 90 degrees. Meaning this is a 90-degree angle, and this is a 90-degree angle, and this is a 90-degree angle, and so is this, okay? So there's some specific things about parallel and perpendicular lines that will help us identify whether lines are parallel or perpendicular without even having to graph them. So parallel lines, they have the same slope. So if you are given two equations with the exact same m term, because remember slope is m, then they are parallel. Now perpendicular lines, they have opposite and reciprocal slopes. So that means if it's a positive, it's a negative. Okay, if it was one's a positive, the other one's got to be a negative. And reciprocal, if it's 1/2, then the reciprocal of 1/2 would be 2/1, or just 2, okay? So perpendicular lines have opposite and reciprocal, talking about sign and the fraction. It's a little bit trickier than parallel lines. So example number 1, we need to determine whether the two equations represent parallel, perpendicular, or neither of the two lines. So if I look at A, I'm going to look at my M. So I'm just looking at this term right here. I know that 2 is not the same as 1/2. So they are not parallel because they are not the same. I also know that this is a positive and so is this. And because they are not opposites, they are not perpendicular either. So these are neither parallel or perpendicular. Neither of the two. Okay, so now let's look at B. I know that my M is 1/3 here, but I don't know what my slope is over here, so I actually have to convert into y equals mx plus b. So I'm going to move the 6x, and since this is a positive 6x, I'm going to subtract 6x on either side. So I get 2y equals negative 6x plus 4. And now I'm going to divide by 2. And when I divide by 2, I divide everything by 2. So this gives me y equals negative 6 divided by 2 is negative 3x plus 2. Now I know what my m is. My m is negative 3. So this one was positive, and this one is negative. So they're opposites. That means they're not the same. So they're not parallel, but they are opposites, so they could be perpendicular. And now I need to look at, is 1/3 the reciprocal of 3? If I put a 1 underneath it, it is 1/3 flipped. So they are reciprocals of each other. So these two lines are perpendicular. All right, I want you guys to try C and D. Try it out. And I'll meet you in example 2. So for example 2, we are going to practice figuring out a parallel slope versus perpendicular slope. So that's all we're doing. We're not going to be doing any conversions or anything like in example 1. So if I look at example 2, I see that my slope is 6. A line parallel to that would also have a slope of 6. But a line perpendicular to that would have opposite of positive 6, so it would be negative, And then instead of it being 6 over 1, it would be 1 over 6. All right, let's do 3. Number 3, a line parallel to negative 6 over 7 would have the same, so negative 6 over 7. And for it to be perpendicular, instead of it being negative, it would be positive, and it would be 7 over 6. Now I want you guys to try 4 and 5. These ones are pretty tricky, so try it out. It's okay if you get it wrong, but try it, okay? Then I want you guys to do your chunk summary, number 1 and number 2. And also, you should probably write a couple questions or connections. And I'll meet you on the back. Okay, so now we are going to write the equation of a line that is parallel and perpendicular to the line that passes through a point. So we're given a line and we're given a point, and we need to come up with the parallel line and the perpendicular line. So on the right, we're going to find parallel, and on the left, we're going to find perpendicular. So they give us the point 4, 3, and they give us a line, so we need to know the slope. So for a parallel line, they have the same slope, and my slope here is 2, so my m here will also be 2 because we're talking about parallel, so same slope. And then I gave you guys point slope form here because that's where you start. You always start in point slope form. So here is my x1, here is my y1 because it's the only point they gave me. So I'm just going to plug it into point slope form. I get y minus 3 equals 2 times x minus 4. And that just came from the point and the slope. Now we need to convert into y equals mx plus b, so I'm going to distribute the 2. So 2 times x is 2x, and 2 times negative 4 is negative 8. And I'm going to bring down the y minus 3. Now I'm going to do the opposite of subtracting 3 because I want y by itself. So I'm going to add 3 on either side. I can't add 3 to the 2x because they're not like terms. So I'm going to add 3 to the 8. And this gives me y equals, because these cancel, 2x minus 5. And that right there is my answer for my parallel line. Now I need to do the same thing for perpendicular. So for the perpendicular line, I have the exact same line that I'm looking at here, but instead of it being the same slope, it's the opposite and reciprocal. So I know this is positive, so I need it to be negative. And instead of it being 2 over 1, it's going to be 1 over 2. And then I plug it into point slope form like I was doing before. So y minus my y1 is still 3 equals negative 1/2 times x minus 4. Then I'm going to distribute the half. So this becomes negative 1/2 x, and a negative times a negative is a positive, and I get half of 4, and half of 4 is 2, equals y minus 3. And now I still have to do the same thing. I have to add 3 on either side to get the 3's to cancel. So I'm going to add 3, I'm going to add 3, these cancel, and we get y equals negative 1/2 x plus 5. And this is the line perpendicular through that point. That's answer number 2. Okay, for my first number 7, because I just noticed there's a typo, for this guy, I'm going to give you guys the answer. This is a we do. So I'm going to give you the answer. I want you guys to try and work it out, see if you get the same answer as me. This is supposed to be number 8, and this will be a you do. This is what you're going to do all by yourself. Okay, so go ahead and pause, try out number 7, the first one, and do the parallel and perpendicular. Do a question or connection. Okay, on this chunk, I don't care where, and I will be back with your answer. Okay, so for the parallel line for number 7, I got y equals negative 3x plus 16, and for the perpendicular line for number 7, I got y equals 1/3 x. If you have plus 0, it's the same thing, okay? Don't freak out if you have plus 0. All right, we're going to finish these notes tomorrow, so have them prepared and ready to go. See you then. Bye.